Okay, ladies and gentlemen, today we're going to talk about a new concept and we're going to begin our study of trigonometry. So, trigonometry seems like a big old scary word, but it's not scary at all. It's actually a lot of fun. And in Math 2, when we talk about trigonometry, we're going to talk about specifically right triangles. Now, we can talk about using trigonometry to find sides and angles of triangles that are not right triangles, but you won't do that until you get to your fourth level math. So before we work with our trigonometry, we need to begin by agreeing on some language. Okay, so that's what I have written here. And we're going to talk about the acute angles, not the right angle. Okay, so the right angle, we don't address it. We talk about these other two angles in the triangle. And when we talk about an angle, so that little symbol right there is a symbol for an angle. You will hear me say theta, Theta. If you hear me say theta, that's just the Greek word for that. Don't worry about that. That's just a technical way to say it, but that just means an angle. Okay, so if I accidentally slide into that language, that just means that angle. So we need to agree on the language that we're going to use. And we talk about the side that when we look at that triangle, we talk about what side is opposite that angle. And when I say opposite that angle, I mean what side is across from that angle. So if I look at that triangle and I say which side is across from it, that is the opposite side. Another side that I look at is which side is adjacent to it. And the word adjacent means next to. Just think about English and its definition. It means next to. But when we say adjacent in a triangle, we mean next to, but not the hypotenuse. So the hypotenuse is always the easy side to pick out. If I look at this triangle, there's the hypotenuse. So which side is next to that angle, but not the hypotenuse? Well, this side is next to that angle, but not the hypotenuse. So for that angle theta, this is the side that is next to it, but not the hypotenuse, and there's the hypotenuse. So here's a triangle. Let's just practice labeling. Say we were looking at this angle theta, and I want to know how long is the hypotenuse in that triangle. Well, that's very easy to pick out. The hypotenuse is right here, and the hypotenuse is 5. And I say, okay, well, how long is the opposite side, the side opposite of angle theta? Opposite is across from it. The side across from it is 3. Well, how long is the side that is adjacent to angle theta? Well, the side that is next to it, adjacent, is 4. So before we work with our trigonometry, we have to know what those terms mean. So when we work with trigonometry, there's 3 basic primary trigonometric functions. There are actually 6 functions, but we have 3 that we're going to work with. Okay, and the 3 functions are the sine function, and the sine function is defined as the ratio of the side opposite the angle to this hypotenuse. I'm going to show you what this all means in just a few minutes. The cosine of an angle is defined as the ratio of the side adjacent to that angle to its the triangle's hypotenuse. And the tangent of an angle is defined as the side opposite that angle to the ratio of the side opposite to the side adjacent. So here it is written as abbreviation. Sine of an angle is the side opposite over the hypotenuse. The cosine of an angle is the side adjacent over the hypotenuse. And the tangent of an angle is the side opposite over adjacent. And the abbreviation, there's a silly way to help you remember that, and that's SOHCAHTOA. And if we were in the classroom, I would do this silly little thing. They laugh at me every year where I wander around the classroom and I trip and I act like I've hurt myself and you all are worried about me and others of you just laugh at me. And I say I have to soak my toa. SOHCAHTOA. SOHCAHTOA. Why do I say SOHCAHTOA? That seems silly. Well, it's a way to remember this. S stands for sine, means. O stands for opposite over hypotenuse. sine is opposite over hypotenuse. D stands for cosine, means adjacent over hypotenuse, ca. TOA. T stands for tangent, means opposite over adjacent. So SOHCA TOA is a way to help you remember. And what I would do is on any triangle trigonometry problem, I would jot that down to help me remember. Now, the last caution I need to tell you before you do these is if you're working with a calculator, you need to push your calculator in degree mode. I'm going to pull my calculator out and tell you what I mean by that. Here's my calculator. And if it's just one of these TI 83 or 84 pluses, and if the memory's been cleared, if you go to mode, and I haven't cleared this memory, but you'll see down here it is in yours will be in radian mode. Now it's not now because I've been working with it, but if you look on your calculator and you hit mode, it is in radian mode. So what you're going to need to do is go mode, come down here and switch it over to degree mode and hit enter. If you're working with technology on the computer, make sure it's in degree mode. I have put an online calculator into Google Classroom and it is set in degree mode, but you just want to make sure whatever technology you're using is in degree mode. Next year, you'll work in radian mode, and that's when we work with waves with sine, cosine, and tangent. But whenever we're working with triangles, we want to be in degree mode. So you want to make sure if you have a calculator that you get it in degree mode. So let's use this new information to solve and find sides of triangles. So here is a right triangle. And I want to use this new stuff that I'm talking about to find unknown sides. So I'm going to write up here, SOHCA TOA. And I'm going to look at my picture, and I see we have a 53-degree angle here, so that's the angle we're working with. We have an X here and a 15 here. So the first thing I want to decide is with respect to that 53-degree angle, which two sides am I dealing with? Well, I always look first of all and say, do I have or can I find or am I looking for the hypotenuse? Well, 15 is the hypotenuse. So I have the hypotenuse, that's one of my sides. And then what side is X? Well, let me see. Is X adjacent or opposite? Well, X is across from the 53. So X is the opposite side. So I am dealing with the opposite side and the hypotenuse. So let me look up here at my choices. Sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, and tangent is opposite over adjacent. So which one deals with O and H, opposite and hypotenuse? That's sine. So I'm going to write that down. The sine of an angle is the opposite side over the hypotenuse. So now I'm just going to fill in the blanks. The sine of an angle, and this angle is 53 degrees, is the opposite side. Which side is opposite that angle? X. Over the hypotenuse. And what is the hypotenuse in this problem? 15. Well, I have written an equation. Now, how do I solve this equation? We're leaving really the new stuff behind. I solve this equation. My goal is to get X by itself. How could I get X by itself? Well, X is divided by 15. I just need to multiply both sides by 15, and that'll get X by itself. I'm going to pull my calculator out again here just so you can see on the calculator. Clear this out. And I'm going to move this up a little bit so you can see it. I'm just going to type in 15. And then if you look across here above the 7, 8, and 9, you have sine, cosine, and tangent. So 15 times the sine of 53, and I'm going to close my parentheses, then I'm going to show you my screen. 15 times the sine of 53 equals 11.98 if I round. So X equals 11.98. The math on these is exceptionally easy. Okay, the only thing that's going to be challenging to you here is getting used to working with sine, cosine, and tangent. So there's our first example. Let's do another one. Example 2. It's another X problem. Solve for X. I am again going to come up here and write SOHCA Toa, because that's going to help me know what to do. So, Toa. That's what I want to memorize. Soak my toe. Sine means opposite over hypotenuse. Cosine means adjacent over hypotenuse. Tangent means opposite over adjacent. And I'm working with this angle. I look at my picture and I say, okay, what side is that 7? Well, that's the easy one to pick out. That's the longest side. So 7 is my hypotenuse. Now, what about that x? Well, that x, it's attached to that 29, isn't it? So that's next to it. So that x is my adjacent. So I have my adjacent and my hypotenuse. A and H, adjacent and hypotenuse. Which of those three functions relates adjacent and hypotenuse? Well, this middle one does. Cosine is adjacent and hypotenuse. So I'm going to say the cosine of an angle is adjacent over hypotenuse. And I'm going to write that down. The cosine of 29 is, now be careful with this, which side is adjacent? Because they're both next to it. But when we say adjacent, we mean next to, but not the hypotenuse. So the side that is next to, but not the hypotenuse is x over the hypotenuse, which is 7. Now, this equation looks just like the last equation, except this time it's the word cosine. But x is divided by 7. If I want to solve for x, I can multiply both sides by 7 to get that 7 out of the denominator. When I multiply both sides by 7, I get 7 times the cosine of 29 equals x. And I can type that into my calculator, just like I typed the last one into my calculator. And if I do 7 times the cosine of 29, I'm going to get x equals 6.12. That's simple. Let's do another example. Another x problem. Solve for x. So let's look at this picture. I'm going to write up here again. So, Toa. That helps me know what to do. Let's look at this 48 degrees, and I'm going to say I always look for the hypotenuse first because that's the easiest for me to see. There's my picture. There's my hypotenuse. Whoops. I don't know the hypotenuse. Okay. So I got to decide which side is which. Well, there's a cross from our opposite. So x is the opposite side. And that 5, it's attached to it. It's next to that 48. So that 5 is adjacent. So O and A, O for opposite, A for adjacent. O and A is this T word, and T stands for tangent. So the rule says the tangent of an angle is the side opposite over the side adjacent. So I can say the tangent of 48 degrees is the side opposite is x over the side adjacent is 5. Well, this looks to be exactly the same pattern. Okay, now they're not always going to be, and you're going to see that in the next 2 examples. But again, we need to get x by itself. X is divided by 5. The way we can undo divided by 5 is we can multiply both sides by 5. These are going to cancel. That's why we did it. So we're going to say x equals 5 times the tangent of 48. 5 times the tangent of 48, and that's actually 48 degrees. And I did this ahead of time just to save some video time. 5 times the tangent of 48 is 5.55 if I round to the nearest hundredth. Now, don't quit watching the video because the last 2 are different, okay? So don't quit because you think you have it, or else you'll miss half the problems. The next example looks very similar, I know that, but there's something that's very important that's different. We're still going to go through the same process. We're still going to write, so Katoa. We're still going to look at that angle, and we're going to say, with respect to that angle, what two sides do we have? Well, I'm first going to look and say, do I have the hypotenuse? That's the easiest to find. There's the long side, the hypotenuse. I don't have it. Let's see, which side is this? Well, 9 is the opposite side, and x is next to it, but not the hypotenuse. So x is the adjacent side. So opposite and adjacent. Opposite, O and A is tangent, but be very cautious. This one's going to look different. I'm going to say the tangent of 32 degrees is opposite. Which side is opposite? Oops, x is not opposite. 9 is opposite. Over adjacent, which is x. Now look at that for just a moment and decide what makes it different. What makes that different than the first three? Have you decided? What makes it different is the x is in the denominator. The x is in the denominator. So this one's going to take us an extra step. Let's first get that x out of the denominator. How can we get the x out of the denominator? Well, let's multiply both sides by x. That'll get it out of the denominator. If I do that, I now have x times the tangent of 32 equals 9, don't I? I got it out of the denominator, but it didn't isolate it. What do I still need to do to get rid of x? Well, x is multiplied by the tangent of 32. So now I need to divide both sides by the tangent of 32. So x is going to be whatever 9 divided by the tangent of 32 is. And that's going to be 14.40 if you round correctly. 14.40. Let's do one more example. I have 2 on here, but I'm going to leave the last one for later on. Let's just do one more example. Let's solve for k this time. So there's my 53-degree angle that I know. I'm going to first look and see, do I have the hypotenuse? Because that's the easiest to see. Sure enough, I do. The hypotenuse is the long side, so that's my k. And then what is 45? Is 45 opposite, or is 45 adjacent or next to? Well, 45 is right next to that 53-degree angle, so 45 is adjacent. If I look at SOHCAHTOA, let's see, adjacent hypotenuse, A and H would be CA, so that's cosine. So I'm looking at the cosine of the angle is adjacent over hypotenuse. So the cosine of the angle, which is 53 degrees, is the adjacent side looks to be 45 over the hypotenuse is x. And this is another problem like the last. We have an issue with x being in the denominator. So as a first step, let's get it out of the denominator by multiplying both sides by x. When we do that, we have x times the cosine of 53 degrees equals 45. But we haven't solved for x yet. Now we need to divide by the cosine of 53 degrees. So what you'll end up typing into your calculator or into the computer is 45 divided by the cosine of 53. And just so you know, when you type it in your calculator, each of these, it will open a parentheses after you cosine, so make sure you close it. Okay, so 45 divided by the cosine of 53, when you type that in, you're going to end up getting, let me turn my page here, 74.77, rounded to the nearest hundredth. So I hope this lesson has shown you that although trigonometry sounds like a big bad word, it's actually a pretty easy way to find unknown sides of right triangles. Tomorrow, we'll learn how to find unknown angles of right triangles, and we'll do some applications with these. As always, if you have any questions, just shoot me an email. I hope you have a super day.